All right, we are about to dive into something that sounds like it was pulled straight out of a sci-fi novel, but believe me, it's a very real and very, very strange discovery in modern physics. Let's get right into it. I mean, seriously, just pause and think about that for a second. Imagine a substance with its own internal rhythm, a constant tick-tock, but it isn't plugged into anything. It's not burning any fuel. It just goes. And here's the part that's truly mind-bending. This happens even at its lowest possible energy state, the point where all atomic motion is supposed to just, stop completely. This material doesn't just bend the rules, it seems to shatter a core symmetry of nature. What we're talking about is a brand new phase of matter, something so counterintuitive that for a long time, scientists argued it was flat out impossible. They're called time crystals.
Okay, so what in the world is a time crystal? Well, to get our heads around it, let's first think about a regular normal crystal.
We all know what normal crystals are, right? Things like diamonds or ice or even a snowflake. Their atoms are locked into this perfect repeating pattern in three-dimensional space. Well, a time crystal does the exact same thing, but in the fourth dimension, time. Its atoms oscillate in a pattern that repeats over and over again, forever. And by doing this, it breaks a fundamental principle called time translation symmetry. Now, that's just a fancy way of saying that the laws of physics don't change over time. They're the same now as they were yesterday and as they will be tomorrow. But a time crystal, its state actually depends on when you look at it. It has its own internal clock, spontaneously breaking the symmetry of time itself. Now, for decades, this was just not considered possible. I mean, it seems to fly in the face of the laws of thermodynamics. How can something move forever without any energy being put into it? So let's walk through this paradox, because it's a real head-scratcher. At its ground state, its absolute lowest energy level, any system should be totally static, motionless, dead still. But a time crystal, even at its ground state, is in constant rhythmic motion. It just seems to defy all logic. It acts like a perpetual motion machine, which, is the one thing we're all taught is impossible.
But here's the incredible twist. This isn't magic. And no, it's not a true perpetual motion machine that you can harness for free energy. The loophole, the secret sauce that makes it all possible, is quantum mechanics. In the bizarre, fuzzy world of quantum systems, things don't have to be completely still, even at their lowest energy. This discovery doesn't break the laws of physics. It just shows us how much stranger and cooler those laws really are. So this is a pretty wild theoretical idea, but how do we actually know it's real? Let's look at the amazing experiments that brought this impossible object to life. And this is where it all gets very, very real. In 2021, a team at Google announced that they had finally done it. Using their Sycamore quantum processor, they actually programmed a system that behaved exactly like a time crystal should. What they did was they took a chain of just 20 quantum bits or qubits, and they zapped them with a very specific laser pulse. This caused the qubits' spins to flip back and forth, from up to down in a repeating pattern. But, and this is the crucial part, the rhythm of their flipping was different from the rhythm of the laser. The system had developed its own stable internal tick-tock. And get this, it wasn't some one-off fluke. Around the same time, other teams at different universities were also creating time crystals using totally different methods. Some used charged atoms or ions trapped in electromagnetic fields. Others used these tiny engineered defects inside of diamonds. And every single experiment pointed to the same conclusion. These things were incredibly stable, they organized themselves into this oscillating state, and they were, without a doubt, a real, brand new phase of matter. The impossible object was officially on the mat. Okay, so this is obviously a huge deal for physicists, but what does it mean for the rest of us? Why should we care? Well, the potential applications are, honestly, they're pretty extraordinary. You see, this new phase of matter has some really unique properties. It exists out of thermal equilibrium, which means it's never really settled. It's also amazingly immune to being disturbed by outside noise, which is a massive problem for quantum systems. It all comes back to that central paradox. It's frozen in its lowest energy state, but it's constantly in motion. And these properties could completely revolutionize our technology. We're talking about things like components for quantum computers that are way more stable than what we have today. Imagine data storage so tough that it could last for centuries without degrading. Or sensors with a kind of precision that makes today's tech look like a blunt instrument. And that stability point, that is the real game changer here. A quantum system's greatest weakness is something called decoherence. That's where it just loses its quantum magic by interacting with the outside world. Well, a time crystal is naturally resistant to that. It could be the foundation for quantum technologies that are far more robust and reliable than anything we can even dream of today. But beyond all the incredible technology, this discovery raises some really deep, fundamental questions about the nature of the universe itself. You know, we've always just assumed that time is this smooth, constant background, the stage on which everything happens. But if matter itself can have its own preferred rhythm, its own repeating pattern in time, does that challenge our most basic ideas about what time even is?
And here's a wild thought. If we can create them in a lab, could they exist naturally? Physicists are now wondering if they might find signs of time crystals in the most extreme places in the cosmos, like inside the super dense matter of neutron stars, or maybe even in the hot plasma of the early universe.
So at the end of the day, this isn't just about a weird new material. It's about a whole new way for matter and energy to behave. It challenges our ideas about the arrow of time, about entropy, and about the fundamental rules that govern our reality. We are really and truly entering an era where matter itself is doing things once thought impossible. Time crystals are just the beginning. They're this profound hint that the universe is far, far stranger and more wonderful than we ever knew. So the question this leaves us with is a big one. If this long-held rule of physics can be broken, what other impossible things are just out there waiting to be discovered?